All right, guys, here we go. We're going to talk mostly about level 8 and level 9 for each of these problems. And we got 5 problems to talk through, so let's try to get to it. For this first one, number 1, I'm going to talk about level 9 because I feel like this will sum up the other ones as well. Okay, so when you're thinking about this, you have to remember that when you're looking at the vertex form of a quadratic function, the h moves the function left and right. The k moves the function up and down. Okay, so for this first problem, we see that we want to move x squared 5 units up and 3 units to the left. 5 units up and 3 units to the left. So I'm going to put plus 5 on the outside of my squared because that's going to move the function 5 units up. And then I'm going to put a plus 3, not a minus 3, a plus 3 into the parentheses, into the squared. And just, for the sake of, well, why is it plus 3? It says left. Check this out. If I were to make a table of values, okay, let's x and y. The easy x would be negative 3, right? And when we plug in negative 3, what do we get? We get 5. And that, my stews, 1, 2, 3 to the left, and then up 1, 2, 3, 4, 5. That is my vertex for this function g. You see how it has to move? It moves to the left when it's plus 3. I don't know if that helps, but anyways, you can just make up rules for yourself and say when it says plus 3 inside the squared, it moves left. If it said minus 3, then it would move right. The outside number is the easy number. If it says plus, you know it's going up. If it says minus, you know it's going down. This one doesn't have that outside number because it only moves right. This one has the outside numbers because it moves down. Okay. All right. So now let's look at this guy right here. All right. Now this guy and this guy are pretty similar. So I'll talk about them both at the same time. So I'm looking at the two x terms, the x squared and the x. Here's the x squared. Here's the x. So what you got to do here is put parentheses around the x squared term and the x term. And don't forget to add the plus blank inside. And you add the plus blank over here. Remember, whenever you add the plus blank, you also need to have the minus blank because you don't want to change it. Whatever you add, you also have to take it away. Now, these two functions have something special happening to them. This one has a negative 1 in front of the x squared. This one has a 3. This one has a positive 1. So the positive 1 doesn't require anything extra. But whenever there's an a, like a 3 or a negative 1, you have to factor those out before you can complete the square. So check this out. I had to take out a 3 from these two terms. So when I do that, I get x squared and negative 6x, and the 3 is sitting on the outside. Over here, I had to take out a negative 1. When I take out that negative 1, I get a positive 1, which is what I want, and then a negative 6 instead of a positive 6. Okay, the next thing I do is I have to find the number that I'm going to add and take away. And so the way we do that is we take the x term, we divide it by 2 and square it. And so in this one, I went negative 6 divided by 2, and then I have to square it. Negative 6 divided by 2 is negative 3. And then when I square a negative 3, that's negative 3 times negative 3, I get a positive 9, which is why you see a 9 right here. Now, the minus number kind of like changed a little bit on the outside here. Right here, so it says minus. I added a 3 right here. Why did I add a 3 right there? Because I didn't want to forget that this 9 is actually being multiplied by the 3. So I'm not really adding a 9. I'm really adding a 27 because 9 times 3 is 27. Now, if I put the 3 right here, I'm not going to forget that because I put the 9 right here and I go, oh yeah, I have to multiply those together. So whatever you factor out, put right there because then you won't forget it. So here you just see the minus 27. Okay, now I'll come to this guy over here in a little bit. Now I have a perfect square polynomial. And if I factor that, I'm going to get x minus 3. Okay, now when you factor it, you can do however you want. A lot of you guys do the box. And what you do with the box is you take the x squared, put it right there, you put the 9 right there. And then you have to have two numbers right here and here that are x terms that will add to give you negative 6. So if you're doing this and you're solving this puzzle, you know that this and this, these two numbers, these two terms are both x's. And then this would have to be a 3 and this would have to be a 3. 3 times 3 will give you the 9. But that would give you 3x right here and 3x right here, which adds to give you positive x, but we need it to add to give you a negative x. So that means we have to make this a negative and this one a negative. So we have x minus 3 times x minus 3, which is why you see x minus 3 squared. And the 3 stays out there. Don't multiply them in. Outside, we have the plus 5 minus 27, and it simplifies to this. Over here, we're pretty much doing the same thing. I factored out the -1, and I put a -1 multiplying to whatever I'm going to minus. Okay, it's because it's a -6. I got the same number to add. I had a 9 right there times -1, and then I had to take away a 9 times -1. And then I simplify, and I get my vertex forms. This one over here, I'm doing the same thing, except I have nasty fractions. So I have a 9 over 2, and I have to divide that by 2, which is the same as multiplying by 1/2. And I get 9 over 4, and then I have to square that to find this number. And that's what I do right here. I also had to take out the -2, so I put the -2 right there. And the rest of it is arithmetic, but I know that that fraction is going to mess up a lot of you guys. Oh, I forgot to mention, I wrote it right here. This is how you guys make a perfect polynomial. You take the b, divide it by 2, and then square it. All right, now let's look at this guy right here. We're only going to talk about one of these. Now, it has quadratics in factored form, but that's not going to be true on your test. So I rewrote this right here and rewrote that guy right there. So if you would have a better chance of doing these problems when they're in these forms, please feel free to write them into those forms. All I did was multiply these out, but I'm not testing you guys on that, so I didn't want to put that on your test. So I scribbled those out, and I'm telling you guys right now, this is what you would see. You wouldn't see the factored form of the polynomials. All right, this is asking us to identify the different parts of the quadratic function. First, the vertex. Now, if I'm looking at this one's in vertex form, so it's kind of easy. It's a positive 3, and then the number that's out here, which is a 0. So we get 3, 0. The x is the axis of symmetry, so I just have to say x equals 3. And then for the y-intercept, I just have to plug in the 0. So that's why there's work right here. I'm actually plugging in the 0 here so that I can find out what the y-intercept is. Okay, over here, we don't have vertex form. Okay, so what we're going to have to do is we're going to have to use a negative b over 2a to find the x in the vertex form. And then we have to plug that -1 back into the function. Okay, so we plug the -1 into this x down here. Simplify it. I get -4, and that's how I get my vertex. Okay, we use the negative b over 2a. Negative b over 2a finds the axis of symmetry. And yes, they're the same number. The x in the vertex is the same as the axis of symmetry. Whatever, I have no way to finish that sentence. And then we have the y-intercept. To find the y-intercept, you got to plug in the 0. So I just go back to this, and I plugged in the 0. I plugged it in over here. You could pretty much do this in your head, but I'm trying to show my work because it says somewhere, make sure you show all your work. So there you have it. That's how you do number 3. All right, number 4. Number 4, we have our, I'm going to look at level 9 only right here. Maybe I'll talk about that fraction here in a second. But you pick the easy x. So I'm going to start with 3. So if I plug 3 in right there, I end up getting 2. And so I put 3, 2 right there, and that's going to be your vertex. The easy x will always give you the vertex. Then after that, I have to pick one other point. So I got 3. I chose to pick 4 for my next number. I take the 4, I plug it in. See, what's 4 minus 3? That's 1. That's why there's a 1 right here. 1 squared is just 1. I multiply by -4, then add 2. I get -2. And so I put that point right here, and then I can just copy that point over here because of the axis of symmetry. Now, for good measure, I did one more point, but you don't have to do that. You just have to have at least the vertex and one other point, because then you can copy that and then trace it, and then you're done. There's your vertex. Now, over here, the second point that I picked was 5, and that was a hard point to pick. And the reason why I picked 5 is because I noticed that the denominator is 4. Because the denominator is 4, if this number right here is a multiple of 4, then it's going to make non-fractions. And that's what I wanted. I don't want fractions to deal with fractions, and so I picked 5. See, if I pick 5, what's 5 minus 1? 5 minus 1 is 4. So 4 squared is going to be 16, which is a multiple of 4. So when I multiply the 3 over 4 times 16, the 4 is going to cancel out with the 16. All right, I also tried 3. Now 3 will give me a 2. So 3 minus 1 gives me a 2. And then when I go 2 squared, that's going to give me a 4 as well. And if I multiply a fraction by its denominator, then it gets rid of the fraction. It's an awesome thing. So you go 3 over 4 times 4, and then you put a 1 underneath it. You'll notice that the 4's get to be canceled out, and you're left with 3. You'll see it all right here. But that's how I found the other points for that one. The vertex is just a 1 in the positive 6. All right, last one, domain and range. Now, you can graph this and then find your domain and range if that makes it easier for you. However, the domain is always all real numbers for quadratic functions, and so I don't have to do any work to find that. And then for the range, I just need to know the y value on the vertex. Okay, now, because this is in vertex form, I know that this number right here is my y value. So that number is either going to be the highest y value, like right here would be a 3, or it's going to be the lowest y value, and right here would be a 3. Okay, so the reason why I know it's the lowest is because the number out in front is positive. There's a positive 1 right here. That means the parabola opens up, and the 3 is going to be the lowest y value. That means all of the y values that are above the 3 are going to be a part of my range. And so that's why I write y is greater than 3, because we have to go above the 3. Over here, oh man, a lot more work to do. What I had to do here is I had to find the vertex using the negative b over 2a formula. So I find the negative b over 2a, which is 1, and then I have to plug the 1 back into the function, which is right here, and that will give me the y value. Over here, that was the y value. It was beautiful. But over here, it's not. Okay, I have to find the x and then plug it in, and then I find the 4. And then I know the 4 right there is actually the highest x value in this one because there's a negative in front of it.